Three metallic plates, out of which middle is given a charge Q as shown in the figure. The outer plate can be earth with the help of which is S1, S2. The area of plates is the same and the gap between the plates G and 3D. Okay, plates G and 3D are small in comparison to the area of the plates. Got it. Answer the following question based on the above passages. Okay, so charge तुमने middle plate को Q दिया, right? Right, okay, or middle को तुमने Q दिया. Okay, that's it. Okay, the charge appearing on the outer surface of the extreme left, both switches are open. दोनों ओपन है then okay so just ignore that case. What charge appearing on the outer surface of the extreme left, ये जो पूरा है ये combined this charge होने वाला है. So like extreme left में you just have to have और इसका जो charge है वो distribute कैसे होगा. Yeah, okay, like that, got it. Okay, so let me guess, it's negative q, yeah, q upon 2, right? तो यहाँ पे plus q upon 2 हो जाएगा, यहाँ पे negative q upon 2 because in the end like okay negative q upon 2 plus q is just q upon 2, so it is the thing. Extreme left, right? Yeah, just B. 23. Charge that will flow to Earth when only switch S1 is closed is connected to Earth. Switch S1 connected to Earth, but then okay whatever. Just like इसके यहाँ पर जो फील्ड रहेगी इस लेफ्ट रीजन में वो जीरो होनी चाहिए और यहाँ पे तो कुछ भी चार्ज है नहीं, so that can't affect anything. So just क्या यहाँ पे चार्ज नेगेटिव क्यू डाल दो. वैसे ये तुमने जो डिस्टेंसेस दिए उनका फायदा क्या है? कुछ भी नहीं. क्यों दिए तुमने डिस्टेंसेस? तुमने पूछा तो कुछ नहीं इस बारे में. जैसे यहाँ पे नेगेटिव क्यू चार्ज फ्लो होगा, या मीन या नेगेटिव क्यू इसमें फ्लो होगा, सो लाइक क्यू विल फ्लो आउट ऑफ इट बेसिकली, राइट? या जस्ट क्यू विल फ्लो आउट. सो सी इज करेक्ट. और क्या है 24 is consider a hollow cylinder of radius r which can roll without slipping on inclined plane. The mass of the cylinder is m and so moment of inertia is equal to mr squared. Cylinder है, inertia okay. The wait what? mr squared. Hollow cylinder, okay, got it. Right. Mass m है, radius okay, got it. The axis of the cylinder is now connected to a fixed wall at the top of the inclined plane by a light spring of spring constant k as shown. Okay. Okay. In equilibrium, the spring has extension x not in the equilibrium. That's it. Okay, got it. The cylinder rolls. Okay. The cylinder is released from position where the spring is at natural length. Got it. Right. So in equilibrium, just x naught. Cylinder roll करता है. Cylinder is now released in position. Okay, from position where the spring is at natural length. The find the angular frequency of oscillations about this around this equilibrium. Yeah, whatever, we don't care कि कहाँ से release किया है. Just you want the small oscillations about equilibrium. Got it. So right. At some certain x value ये ऐसा है कि वो equilibrium attain कर रहा है, क्योंकि वहाँ पे जो let's say मतलब forces friction force है. I think the forces are not the way to go. The torque equations are the way to go, right? Yeah. So contact point के about स्लिप नहीं होगा, दैट्स व्हाट यू आर अज्यूमिंग. और ये क्या है? विदाउट स्लिपिंग ऑन क्लिपिंग. गॉट इट. सो ऑन इक्विलिब्रियम क्या हो रहा है? जस्ट ये जो कंबाइंड टॉर्क है बिकॉज ऑफ ग्रेविटी एंड बिकॉज ऑफ दिस थिंग अबाउट दिस पॉइंट दैट्स 0, राइट? एंड देन आफ्टर सम एक्सटेंशन, सो यहाँ पे x आ गया, यहाँ पे एक्स्ट्रा का फोर्स कितना आएगा? kx. ग्रेविटी से उतनी है, वी डोंट केयर अबाउट दैट. ये जो कंपोनेंट है वो तो वैसे भी फर्क नहीं पड़ता अपने, उसका नॉर्मल फोर्स कोई फर्क नहीं पड़ता. अबाउट दिस पॉइंट, about the contact point, that is. You should actually say about any point on this plane. यहाँ पे जो angular momentum का चीज होगी, but then yeah, तुम्हें पता है कैसा होता है. Just center of mass का angular momentum plus center of mass के about angular momentum, right? और वो in the end just turns out to be ये और ये दोनों सेम ही रहेंगे because with respect to both of them same momentum आने वाला है. So just contact point देख लो ना. Yeah, तब कैसे ही था, right? Of course, about मैं क्या करना रहा था? God, right? हाँ, so extra force kx यहाँ पर just like extra torque जो है, which is actually in this direction, like k rx, and that upon the inertia now, which is 3 upon 2 mr squared upon about this point that's equal to alpha. But actually ये ऐसे जाने वाला है, so like alpha times r is just acceleration, so like this times of r is like just r square, the free cancel हो जाएगा. This thing is इस साइड में इसके acceleration negative है because yeah actually negative यहाँ पे चाहिए, यहाँ पे you know ये negative direction whatever. So just a is equal to what? A is just negative 2k upon 3n then x. So again like 2 pi square root of 3m upon 2k. That's the angular frequency. Oh, you just want just want angular frequency. You don't want time period. So taking the square root of 2k upon m, which sorry upon 3m. That's not there for some reason. Wait, is that wrong? Oof, it's not mr squared upon 2. It's actually a 2mr. Right, 2mr squared है because hollow cylinder. So yeah, well that explains it. तब क्या मिलेगा अपने को यहाँ पे? Just a equal to negative k upon 2m. ये r square मर जाएगा इसे times x. So just square root of k upon 2m, which is a. Next question 25. So suppose instead of being a hollow cylinder, another solid cylinder of same mass and same radius is used. Nah, it's a different angular frequency now. Cylinder oscillates with lesser angular frequency and amplitude के बारे में क्या बोल सकते हो? टॉर्क की इक्वेशंस वो जीरो चाहिए ना? Yeah. So फर्क नहीं पड़ता इनर्शिया क्या है, टॉर्क जीरो चाहिए. So still same amplitude रहेगा in that case. So जो उसकी angular frequency is like square root of what? Square root of 3k upon not right. Square root of what? 2k upon 3m, right? So इसमें 2 upon 3 आ रहा है, इसमें just 1 upon 2 आ रहा है. This one is bigger. So higher angular frequency and same amplitude. So I think C is correct. Next question 26. Oh shit, ये तो खत्म हो गया. Okay, अब क्या है next? Substitute type questions. ठीक है. First question. Wait, but मैं इसका आंसर कैसे दूंगा? I don't know. Try करते हैं. Two small blocks of mass m 3 kg are kept on horizontal circular platform on two mutually perpendicular radii of circular platform. Okay, on two mutually perpendicular radii at the equal distance from center of table. Got it. The blocks are connected with और क्या rough है platform? कुछ तो बताओ. The blocks are connected with a string of something which is just taut when the platform is not rotating. Okay, coefficient of friction between the platform and okay, so blocks are connected, right? Okay, right. Let's go to whatever, which is taut when the platform is not rotating. Coefficient of friction between platform and block is mu equal to 0.1. Then the maximum angular speed of platform about center so that the block remains stationary relative to platform. Mu दिया आपने को and yeah, that's all they actually gave us. Got it. So कैसा है ये perpendicular, okay, masses तुम्हें दी है. Q mutually perpendicular radii at equal distance from the center of table. Okay, और ये जो length है it's just 2 meters over there, तो ये sort of 2 रहेगा. सबको R समझ लिया. Mass कितना है यहाँ पे? just 3 kg, 3 kg. Okay. Mu is what? 0.1. Okay. Right. So maximum frictional force कितना हो सकता है? just like yeah, जो भी है. Maximum frictional acceleration बोल दूँ, whatever. Maximum angular speed of platform so that the blocks remain stationary. यहाँ पे कुछ भी टेंशन होगा, यहाँ पे कुछ भी टेंशन होगा. It can only pull. It's a string after all. तो ठीक है. What about the complete system के लिए मैं देखूँ तो that's not the best way to be doing it, right? अच्छा, अगर ये मतलब स्टार्ट होता है फिसलना तो कैसे होगा? एक्चुअली ऐसा फिसलेगा नहीं, right? Because or not, just omega in that direction. So omega is constant. Equations अगर अपन सिर्फ इक्विलिब्रियम के लिए इक्वेशंस लिखते हैं and then try to find critical points. Yeah, that's a good enough thing. So ठीक है, तुम्हारे सेंट्रीफ्यूगल फोर्सेस आएंगे यहाँ पे and टेंशन आ रहा है यहाँ पे. Okay, और क्या? then this like just the friction force, of course. Yeah, these are like tendencies to move in that direction. And then there should be friction force such that वो cancellation हो जाए. But it can point in any direction. So अब मैं वो कौन सी direction को choose करूँ? Yeah, that's kind of a complicated thing. Omega is in that direction. Maximum omega such that when they start moving, everything will become complicated. Symmetry, is symmetry a good way to do this thing? When alpha to 0 है, so how do you take out friction though? Friction is just in this direction. Wait. Tension force is like tension भी variable है. Tension is also variable for some reason. That's not going good. तो अब क्या? Tension is variable and then ये force इस direction में है. Can they become zero combined? Well, no. So what do you want? Uh, perpendicular to this guy. I don't know. Something's not making sense. Maximum speed. I don't get it. Ki just stop when the platform is not rotating. Okay. So the platform blocks this thing. Maximum angular speed of the platform about center so that the blocks remain stationary to the platform. I mean, okay, your friction is in which direction? I don't get it. हमारा टेंशन तुम्हें पता है नहीं. So unless अपनी डायरेक्शन पता है, we can't figure out anything. अपने को मैग्नेट पता है ना एटलीस्ट. Well, yeah, that's one thing. अपने को ये भी पता है कि ये कितना रहने वाला है. Okay. Our friction is like variable. It can be anywhere. That's a problematic thing because blocks remain stationary related to platform, right? Maximum angular speed. I don't understand. So इनकी टेंडेंसी कहाँ पर मूव करने की? कंबाइंड डायरेक्शन एक कहाँ ऐसे कुछ भी रहेगा ना? Yeah. Suppose तुम्हारा टेंशन एक्टिव है, then it's like friction is in this direction, that direction, and what not, right? Of course. So what do I do? What do I do? Uh, oh, I know. Okay. You know, इसको अपन ब्रेक कर सकते हैं इन दिस डायरेक्शन इन दैट डायरेक्शन, और फिर इस डायरेक्शन के लिए यूनिट ऑफ फ्रिक्शन, इस डायरेक्शन के लिए फ्रिक्शन फोर्स. सो अपने को ये एक कंपोनेंट तो मिल जाएगा, बट देन ये जो बाकी कंपोनेंट बचा हुआ है वो अभी अपने को कैंसिलेशन करना पड़ेगा ना समहाउ, कि वो अपने आप जीरो हो जाएगा. वी डोंट नो फॉर श्योर. या वी डोंट नो फॉर श्योर अनफॉर्चुनेटली. शिट. वी डोंट नो फ्रिक्शन कहाँ पे एक्ट कर रहा है. दिस इज नॉट मेकिंग सेंस. अनलेस वी नो अपन ये नहीं कर पाएंगे, राइट? और सेंटर maximum angular speed or center so that mutually perpendicular radii, whatever, we don't care. It's not, the platform is not rotating. Social friction between the platform is 0.1 maximum speed. The platform. With respect to platform, of course, yes, और ऐसे एक pseudo force है यहाँ पे, tension forces लग रहा है. But अपने को tension friction पता नहीं. This is like a bunch of equations for this guy, right? Okay, tension is just a variable, maybe ये तुम ऐसा कह सकते हो कि tension is just a variable, and then but then फिर तुम tension को maximum रख दो and okay. So think on like this, कि पहले friction act करेगा and then tension will act, right? Yeah, well that explains it. And ये already tension इसमें था start में. So okay, interesting. So already जो tension था, which means वो already rest पर तो थे, and okay, like only a part of friction is acting up. और हो सकता है कि ये इसको तुम replace करो एक string, okay, एक spring से somehow. Yeah, इसको जो भी Young's model, sorry, जो भी होगा, right? There's some kind of extension in the string because of which यहाँ पे tension है, just dot, right? Initially फिर tension almost zero था, like 0 point something. Yeah, very close to zero, but more than that. So just dot. So initially tension zero था, उसके बाद में it just starts to rotate. So then, but we want the final condition कि वो क्या. So पहले तो फ्रिक्शन एक्ट करेगा, पहले तो टेंशन जीरो रहेगा, तो फिर सिर्फ फ्रिक्शन एक्ट करेगा, जस्ट या लाइक दिस. उसके बाद में फ्रिक्शन कम होने लगेगा, तो एट दैट पॉइंट यू विल हैव टू पुट इन सम टेंशन फोर्स सच दैट वो कंबाइन होके एक्ट कर पाए, राइट? यस. सो टेंशन इज इन दिस डायरेक्शन, यू वांट इट टू बी अपोजिंग दिस. मैक्सिमम अपने को चाहिए इट्स लाइक इन दिस डायरेक्शन, तो फ्रिक्शन डालना पड़ेगा, राइट? बट या गॉट इट. सो जस्ट इसको अपोज करने के लिए फ्रिक्शन शुड बी इन दिस डायरेक्शन. ये एंगल बाइसेक्टर, यू गेट थिंग. ओके, नॉट एग्जैक्टली एंगल बाइसेक्टर, जो भी है. सो एज यू ऐड टेंशन, तुम्हें फ्रिक्शन की डायरेक्शन चेंज करनी पड़ेगी. Okay, started to make sense just a bit, but so friction is at maximum magnitude already, और as you move tension, so तुम इसकी वैल्यू चेंज करते हो, तो ये एंगल चेंज हो रहा है, and then yeah, so as this angle changes, इसका कंपोनेंट चेंज होगा, राइट? Of course तुम्हें इसको, right, okay, you have to have that in any way. Okay, तो वो वाला तुम्हें करना ही पड़ेगा, विच मीन्स कि एट क्रिटिकल कंडीशन इसका ओके ओके लेट्स एक्चुअली डू दिस थिंग, लेट्स सी क्या होता है इसमें। तो ये जो पॉइंट मास है इसके लिए यहाँ पे टेंशन विच इज द वेरिएबल क्वांटिटी, ये एंगल इसका थीटा वी नो दैट इज 45 डिग्री। ये जो चीज है तो द एक्सेलरेशन बिकॉज ऑफ दिस गाय जस्ट व्हाट इज जस्ट ओमेगा स्क्वायर आर, आर वी नो जस्ट दैट वो अपन कर लेंगे, एंड देन दिस फ्रिक्शन which is acting in some direction like it's like theta आ जाएगा just, and friction we know that is maximum so just फ्रिक्शन एक्सेलरेशन कितना होगा म्यू जी इन दिस डायरेक्शन, इसको मैं टी अपॉन एम स्मॉल टी बोल रहा हूँ यू नो, सो उसकी वजह से जो एक्सेलरेशन होगा फॉर इस मास राइट। ओके सो व्हाट यू हैव जस्ट यू नो म्यू जी कोसाइन थीटा प्लस टी अपॉन रूट ऑफ 2, you know what actually अगर ऐसा है then you can just actually split this as some t in this direction, some t, same t in that direction, right? So just plus t बोल दो यहाँ पे। अब t is not t upon m but t upon m upon square root 2, but whatever. So ये जो चीज़ है that is equal to omega square r and also mu g sin theta plus, okay this is just equal to t, right? So use this and put that over this, like what do you get is like mu g times cosine theta plus sin theta. Ah, okay, understood. Understood. This is equal to omega square r. Right. So here's the thing. Acha, which means like what? Omega square is equal like bigger than omega. जो भी है. Mu g. So something with sin theta upon r, which is like ये जो चीज है this is just इसकी minimum value कब होती है? It's like square root of, yeah, that's the minimum value, right? Or the maximum value. No, that's the maximum value. It's less than or equal to this guy. So it must be less than or equal to this guy. Otherwise नहीं हो पाएगा. It's just mu g square root of well, 2, right? Yeah, sort of 2 on r. That explains it. Yep, that should do it. So just omega is less than or equal to square root of this guy. Just to figure this out. Mu कितना है अपना 0.1 times g is just 10. We are assuming just यहाँ पे 1 आ जाएगा square root of 2 upon r is also square root of 2. तो just cancel करके 1 हो जाएगा, omega is less than or equal to 1. Yep. ये अजीब था, बहुत ही ज्यादा कंसेप्चुअल निकला ये, सब्जेक्ट की टाइप है ना, so yeah. But it's still weird कि ये somehow हो रहा है. Anyway, second, a uniform cylinder of radius r is spin about its axis at angular velocity something placed between two perpendicular walls. Question of friction between the walls and cylinder is mu equal to 2. Then how many turns will that cylinder make before it stops? R दिया है, velocity omega naught दिया है, placed between two perpendicular walls. Question of friction between the walls and the cylinder is mu equal to 2. Then how many turns will पहले तो कुछ अपने को चीजें स्मॉल करनी पड़ेगी, जैसे यहाँ पे n1 n2 चीजें या थिंग। सो फ्रिक्शन ऊपर एक एक्ट करेगा, यहाँ पे वो एक्ट करने वाला है। स्टार्ट विद दिस, सपोज ये नॉर्मल फोर्स यहाँ पे है एंड बिकॉज ऑफ दैट इज लाइक फ्रिक्शन फोर्स, और ये ऐसे मूव कर रहा है लाइक फ्रिक्शन फोर्स इन दिस डायरेक्शन जस्ट म्यू टाइम्स नॉर्मल फोर्स वाज काइनेटिक फ्रिक्शन। देन ओके, तो यहाँ से जो फोर्स लगेगा दैट शुड बी म्यू टाइम्स n, राइट? बिकॉज equilibrium, right? Okay, which means कि जो upward force है is just mu squared n over there, and नीचे mg लगने वाला है, which means that n plus mu square n is equal to mg. Okay, awesome, right? So you can get n in that way. अपने को torque निकालना, tau is what, or like deceleration जो भी है, okay, वो कितना होगा? just ये जा रहा है, ये जा रहा है like mu plus mu square times n, and that terms of r torque नीचे, we just want alpha by the way, and this upon the inertia about this guy, right? Yeah, just mr squared. क्या है? uniform cylinder, right? Okay, mr squared, solid cylinder I believe, mr squared upon 2. Yeah, they should do it. So एक r cancel हो गया, just this thing, just like what, 2 mu plus 1 n upon mr, that's what alpha is. Yeah, so just, and what do you want? How many turns before it stops? So initially omega naught में दिया है, omega naught, wait, you don't want that, you want the number of turns, right? Okay, so what do you know, like using the same kind of, okay, so this is just negative d omega upon dt, which is a negative d omega upon dx times omega. So yeah, omega square, got it, omega square का differentiation, right? So like omega square finally just 0, so like omega naught square अभी negative चाहिए सिर्फ, so to 2as or something, right? ऐसा होता है. So 2 alpha is in this case, which is like 4 mu plus 1 n upon mr. You got theta, so वो theta समझ जाएगा. And then what you actually want is like theta is just 2 pi n, so the number of turns, right? तो ये नीचे आ जाएगा 8 pi mu plus 1 n ऊपर mr omega naught square. What is n? N is just mg upon u square plus 1. तो ये m का है, this is this thing calculated, right? r कितना है अपना, so एक बार इसमें लिख रहा हूँ r omega naught square mu square plus 1 upon 8 pi mu plus 1 times g. डायरेक्टली एरोरो से तुमने प्रॉब्लम चुराया समझ रहा है अपने को, बट स्टिल मैं पूरा डिराइव करने वाला हूँ बिकॉज मुझे कुछ भी याद नहीं है जो मैंने किया. आई थिंक आई शुड रीड दैट वंस अगेन, यू नो, जो मैंने डिराइव किए थे सारे फॉर्मूले मुझे एक बार वापस करने चाहिए. ओके ये कितना हो जाएगा, जस्ट r is 3, omega naught is 40 pi, god radius में ओके ऐसा ही, लेट्स गुड 1600 times pi, oh god mu square plus 1 mu कितना है 2. 2 are you serious, काफी बड़ा नहीं है ये अपनी. 5 upon 8 pi times 2 times 3 times of g is I'm gonna assume it's 10, right? Good. तो ये क्या है, pi मर गया, just what like 8 to 16, ये गया just 100, ये 10 हो गया यहाँ पे, just ये 3 मर गया, just what 10 times of 5, that's it I guess. So just 50 turns. Next question. Third is a long horizontal rod has a bead which can slide along its length and initially placed at a distance L from one end A of the rod. Long horizontal rod bead which can slide along its length placed. This is L from, okay, the rod is set in angular, oh god ये वही है वो वाला क्वेश्चन जो कि मेरी जान खाता है. The rod is set in angular motion about O with constant angular acceleration. Oh, acceleration नया है कुछ तो इसमें. If the coefficient of friction between the rod and the lid and the bead is mu is equal to 1 and the gravity is neglected, find the time after which the bead starts slipping. Okay, that's not that bad I guess, right? So ये कैसा है with respect to the rotating reference frame, यहाँ पे जो bead है is that is like what initially at a distance L from the end, right? तो ये end L पर है. Okay, so at some certain instant omega is like alpha, right? इसका जो pseudo force पे लगने वाला है, कैसे कैसे लगने वाला है, it's like alpha in this direction, so just that force, or you could always skip this or just, you know, think about the actual acceleration of this graph, which is like alpha r in this direction, alpha L in this case, or omega square L in that direction, pseudo force actually, sorry. So actually में यहाँ पे omega square L लगने वाला है, actually acceleration इसका ऐसा है. Yes, well this is provided by normal force और यहाँ पे friction force लगेगा, right? Just the friction force is equal to m omega square L, and this is like less than or equal to normal force times mu, which is just mu alpha L, so m alpha L, sorry, right? I mean that's the thing, of course. और क्या हो सकता है, I guess so. Yeah, कुछ और मैं मिस कर रहा हूँ क्या इसमें? I don't think I am. Gravity or something, horizontal rod, maybe gravity I'm missing. Shit. जो bead है, oh god, अल्फा दिया है, ये लेंथ तुम्हें दी है, कुछ फ्रिक्शन इज गिवन. शुड आई कंसिडर ग्रेविटी और नॉट? आई डोंट थिंक आई शुड. जस्ट इसको सॉल्व कर लो, इसको और पागलपन रहेगा नहीं. या उसने जी तो कुछ दिया नहीं, सो जस्ट डोंट थिंक अबाउट इट. क्या होगा, ये m कैंसिल हो गया, जस्ट ओमेगा स्क्वायर इज लेस देन और इक्वल टू म्यू टाइम्स ऑफ अल्फा, राइट? या सो omega is like what alpha times t, so just what alpha t square is less than or equal to mu, I believe. Yep, that should do it. So t less than or equal to square root of alpha mu upon alpha, only उस टाइम के लिए ही ये रहेगा, right? So this is the point where it breaks off. Okay, so कितना है? Mu is just 1, alpha is what? 1 as well in SI units, square root of 1. Yeah, SI units में just 1 आ रहा है. 1 second, I believe. Yep. So third का answer 1 second. Next question, fourth. Fourth is two charges Q1, Q2 placed 3.03 meter apart. How much work in bringing third charge from the third vertex of an equal triangle? What? From the third vertex of an equal triangle? From each of the what? Okay. Okay, two form equal triangle. Okay. 0.03 meter from each of the two charges. ये पॉइंट्स ओके गॉट इट नो बिग डील वी कैन डू इट सो वो तो इंफिनिटी पे था ये फिक्स्ड चार्जेस है राइट या दीज आर जस्ट फिक्स्ड 7 minus 5 is like 2 so just 2 micro 2 times of 10 power negative 6 right just k we will plug in later kq times q so third charge of what 5 microcoulomb just distance of 5 times 10 power negative 6 right somehow ये positive हो जाएगा okay upon r of course okay this is not that hard 3 times of 10 power negative 2 right yep. K is what? 9 times of 10 power 9. Shall we calculate? So, ये हमारा is just 3 over there. 3 times 10 power 9 times 10 power just 1. 10 power negative 12. It's like 10 power negative 2. Just point. Oh, नीचे भी है ना 10 power negative 2. वो पड़ जाएगा just 10 power 2 बोलते हैं. Just मैं तो मर गया. Just 3. 3 is the thing. So, 3 joules. Yeah. Next question. Fifth. Fifth is well, actually ये fifth था. Fourth वो है. Got it. Fifth का 3 joules. Fourth is capacitor of capacity something is charged to potential of 100 volts. The charging battery is then removed and now C1 is connected to another uncharged capacitor of C2 equal to 4 microfarad. One plate of C2 is earth as shown in steady state. The charge C1 in microcoulombs will be. पहले 100 volt तक charge किया C1 को. Then charging battery is then removed. And now C1 is connected to another uncharged capacitor of C2. Okay, one plate of C2 is earthed as shown. In steady state the charge on C1 will be. So just ये potential difference को गायब करना है. That's all you want, right? अच्छा ये positive है in both cases. यहाँ पे negative charge वैसा ही रह जाएगा यार लेकिन because yeah well that's kind of not good. Uh, the charge on C1 will be interesting. But okay so like along this हमारा potential making sense. Unless of course तुम्हें potential गायब कर डालो इस तरह से. ये फील्ड प्रोड्यूस नहीं कर रहा है राइट इसमें जो पोटेंशियल जीरो ओके नहीं C1 में सॉरी C2 पे जीरो होगा ना यार ये तुमने अर्थ भी कर दी कोई फर्क नहीं पड़ता कुछ नहीं होता ये जीरो अभी भी इसमें चार्ज जीरो रहने वाला है राइट पोटेंशियल डिफरेंस है यहाँ पे और यहाँ पे है बट क्या फर्क पड़ रहा है ये अर्थ तो नहीं किया तुमने सो नो बिग डील state charge on C1 will be just what C times V in क्या microcoulombs is like 200 microcoulombs that's it okay इसका just 200 sixth two charges so fifth sorry due to excess pressure of surface tension find the charges in the radius of a liquid drop of radius 1 meter surface tension is this thing but modulus is this thing oh sorry changes in the radius changes in the radius of a liquid drop of radius 1 millimeter surface tension what do you mean by that changes in the radius of a liquid drop of radius 1 millimeter surface tension is this thing bulk modulus is this okay I think I'm getting what okay तो इनिशियली सपोज सरफेस नहीं थी सो ये वाटर के अंदर जब था वो वॉल्यूम देन वो वॉल्यूम जो थी और फिर बाद में वो वॉल्यूम तुमने एयर में ला लिया तो उसका डिफरेंस क्या हुआ राइट या वो केस में बाहर का प्रेशर अपन सेम एटमॉस्फेरिक प्रेशर मान लेते हैं ओके कूल सपोज इनिशियली उसकी क्या इनिशियली इसका जैसे कैपिटल आर था रेडियस जस्ट 1 मिलीमीटर 3 व्हाटएवर सरफेस टेंशन क्या दिया तुम लोगों ने अपने को 7 पॉइंट ओके जो भी है 75.10 power 3 या जो भी 3/4 टाइम्स should say 3.40 I guess. Okay, so T is just that. और क्या bulk modulus is ये चीज और 4 times is like 4 or just 1 5/4 times 10 power 8 SI units I believe. Okay, got it. So कैसा हो जाएगा just like change in pressure or something, right? But yeah, change in pressure कितना होने वाला है? Just surface tension which is like और ये क्या है? It's a drop like 2T upon R is, or I should say small r. So yeah, that's the change in pressure for the volume. Okay, upon nothing. Okay, this is just equal to bulk modulus times जो change हुआ volume में, which is like r cube minus r cubed upon जो initial volume, which is r cubed. I believe that's good. Or you can just always do this thing 3 r squared dr, right? It's just 3 bulk modulus. अच्छा ये भी इतना चेंज तो नहीं हुआ होगा ना, फिर assume actually no, we should probably do it the proper way. This is the thing, right? Yeah. I mean, even though अपन assume कर सकते हैं कि r is actually not that big, but then why? इसको solve कर लो, you are good to go. 2t upon b is equal to what? It's just 1. वो तो गया. r minus r power 4 upon r power 3. Probably just best to assume कि ये चीज approximately 0 है, you know. Yeah. It's like maybe तुम्हें delta इसमें डालना ही चाहिए था. You want the change, right? Because of surface tension. Okay, whatever. Probably have to see क्या हो रहा है इसमें. Just 10 तुम्हारा कैपिटल R काफी छोटा है. Okay, whatever. देखते हैं ना ये जो चीज रहेगी is this like big or small कि क्या हो रहा है, right? This is like less than 1 anyway, so ये चीज इसमें what, right? Okay. Oh, okay. This is like actually very much close to 0 in fact, and this is I guess close to capital R or less than that at least. So ये चीज क्या होगी? 2t upon b is 2 times of each is upon that. It's like okay, 6 upon 40 upon 5 upon 4 times 10 power 8, which is what? 10 आ जाएगा अभी नीचे. नीचे क्या है? Just 5 times of 10 power 9 that is. Yeah, pretty small I believe. R is approximately how much is 10 power negative 3 in comparison to this guy like 10 power 9 वगैरह आ रहा है. It's just very small. तो ये जो चीज़ है, this is like close to whatever. You want what? I think enough. Then you just assume that R is approximately capital R. And then ये जो चीज़ रहेगी, this dV upon V thing is the same thing as saying dr upon R. So just delta R upon R, right? Yeah. I believe this works. So ये तो मर गया. Just this thing. Delta is just 2t upon b, which is just this thing basically. It's like 1.2 times 10 power negative 9. Yeah, let's just do it. Or like 12 times 10 power negative 10 angstrom. 12 angstrom, right? Yeah. Got it. Next question. हाँ ना, काफी छोटा चेंज हुआ इसमें तो. Shit. dv upon v is not just, oh, it's like 3 times of dr upon r. यहाँ पे 3 चाहिए था. So actually में यहाँ पे okay, this is what should be thing. This thing upon 3, huh? 0.4. Okay, 4 angstroms. Big deal. And what do you want? हाँ ना, उतने तो चाहिए. Just change in radius in angstroms. Just 4 angstroms, of course. Next question. 7. 7 is a uniform solid ball of mass 10 kg, radius 2 meter, rotate about axis passing through its center. The angle rotated by the ball has the expression of this form. Okay, what will the force moment acting on the ball at t equal to 2 seconds? Like dl upon dt, I guess. और क्या कर सकते हैं? कोई और में कुछ इसमें दिया ही नहीं मुझे. Right. So dl upon dt, that's like, so omega कितना होगा? Omega is, or let's do I alpha. That also works. Just 2bt plus 3ct square, right? It's like what alpha in that case? Yeah, that's the thing. Of course, just 2b plus 6ct, right? तो चाहिए I alpha, the uniform solid ball, radius 2 meter. Just want what? 2.5 5 because it's solid ball. Mr squared times alpha, which is this thing, just 2b plus 6 ct. So like what? 4 upon 5 m kitna hai? 10 kg r squared. R is 2 squared is 4. In terms of b plus 3 c times t. T is just 2. So like, okay, just 2 times of 3 c is like 6c once again. Yeah. B is 4, C is -1. So just, oh shit. वो -1 है क्या? Oh, that was unexpected. Yeah, it's like decreasing, huh? Interesting. जो भी है, put in the values. So B is 4, C is -1. Just formula system, just -2. But magnitude में just 2 आ जाएगा, right? Just want the magnitude anyway. This should work out. Yes. Which is like what? Just 8 square, 64 newtons. Assignments, I believe. Next question. Okay, if AC voltage 100 volt is applied between points A and P, then the current of 1 ampere and phase difference between current and voltage will be phi, delta phi equal to 37 degree. Okay, if the same voltage is applied between B and C, so A and B के बीच में क्या है? AC voltage 100 volts, and then current of 1 ampere, magnitude I believe, or it's like RMS, I don't know. The phase difference between current and voltage will be delta phi is equal to this thing. Okay, ठीक है. If the same voltage is applied between B and C, then the current of 5 ampere delta phi. What will be the impedance in the chain if the same voltage applied between A and C? Okay, one of nearest integer. Basically अपने को Z निकालना है, right? That's all you want. तो पहले इसलिए Z क्या है? AC voltage 100, current कितना है? 1, just 100 is our impedance, like V upon R, sorry, V upon I, and then yeah, and so the phase difference, like, yeah, assuming he was saying चीज होगी, yeah, okay, got it. So यहाँ पे 5 है, it's like what, 100 and then e power I then 37 degree जो भी है, and then plus 5 like 20 e power I times 53 degrees. Got it. It's like क्या हो जाएगा, just 37 degree के लिए 3 iota and then 4, just okay, 20 times 4 plus 3 iota plus 4 times, so 3 plus 4 iota, right? I mean that should be the thing, I guess. दोनों क्या, just resistor inductor, resistor inductor, those are the things, of course. Okay, whatever, impedances में मिल गए. Okay, wait, ये ही impedances थे, right? Just add them all, of course. Yep. So just क्या 80 plus 12, I believe, like क्या करते थे मैं? हाँ, 80 plus 12, which is a 92 plus what do we have? 60 plus what? 16, which is like 76 iota, right? Yeah, should be doing it. Or you have to take 4 common, whatever. अच्छा, what will be the impedance in the chain if the same voltage is applied with A and C? तुम्हें सिर्फ impedance चाहिए यार, इतना क्या कर रहे हो? हाँ, that's actually very easy. So इसको like we can write as 4 times of what? 5 times of this thing is 20 plus 23, then plus 15 plus 4, I believe, which is 19 iota. So 4 square root of squares. God. 23 का square plus 19 का square. Okay. It's like 4, 12, 23 का square कर दिया, 23. Just 6, 9, and then 0. 4, 6, which is 5 to 9. So 5 to 9. It's like what? 361, I believe. 4 minus 1 square. Sorry, 9, 20 minus 1. So whatever. Which is what? 4 square root of 0, 1 carried on, just 3, 9, 890. Interesting. देखा तो कभी नहीं करा. 10 times 89, I have not seen that yet. Just 8, 9. Yeah, 890. What is this? Is something going wrong? 23 का square CC किया. Yeah, 509. And this thing is 361, so it's gotta be sort of 890 or something. Approximately 900 बोलो यार. Just 4 times, so it's like 120 ohms. Shit, nearest integer. Are you serious? ये लोग मेरी जान लेना चाहते हैं. That's it. Okay. Okay, fine, whatever. Square root of what? Just 890 times 4, 16 actually, sorry. like 89. 6 8 are 48, 6 9 54, 4 5 58. ऑनेस्टली लोग इसे जान लेना चाहते हैं और कुछ नहीं है। ये क्या है यार, सीरियसली ये कैसे गंदे वैल्यूज दे रहे हो तुम लोग मुझे। 1424 अनलेस मैंने कुछ भी गलत किया है इसमें, विच आई डाउट इट, बिकॉज नहीं मैंने कुछ गलत कैसे किया सकता है। लाइक 100 अपॉन दैट राइट, करंट इज दैट 20 आएगा, यहाँ पे 100 आएगा। या दैट्स हाउ इट वर्क्स। टेल मी ऑनेस्टली मैंने क्या गलत किया, कुछ भी गलत नहीं किया। दिस इज द थिंग, then this should really just be the impedance. Okay, whatever. Chain if the same what is ठीक है ना, front of nearest integer we'll just do it. चलो फिर करते हैं। दो दो जीरो हो गया I guess. Okay, just 1 1 minus 0 1, just start at 0 0 4 2 1 2 something, right? Probably just 2, nah बहुत बड़ा हो जाएगा। just 1 in that case, 21 21, so distance of 1 is just what, 1 I believe. It's just 21 is it. Okay, 2 won't work of course, so like 2 1 finish 4 आ जाएगा and 0 as well. Okay, so this is what 2 2 something, 2 2 something 10 के पास में है, you know, say 9 of course. Okay, distance of 9 कितना होता है, just 1 8 carried on, 18 and 8 is 26, 6 2 carried on, 2 carried on, and 18 and 2, right? It's like 2 0 of course. So ये कितना हो जाएगा 9, and then ये हमारा just 13 minus 6 is 7, 0 0 whatever. आगे एक पॉइंट डालना पड़ेगा। anyway ये क्या, just 3 shit 2 3 8 something, 2 3 8 something, like what, 3 probably have to छोटा, so approximately 119 is the answer, right? Yeah, 19. Next question. 8 done, let's go to 9. किस टाइप के क्वेश्चंस आ चुके हैं यार। An arrangement of smooth pair of long conducting rails which are resistanceless are joined to a charge capacitor. The rails are connected by a rod of mass m, length L, resistance R. Vertical magnetic field are uniform. The rod is initially at rest. Smooth pair of long conducting rails. Okay. Which are resistanceless joined charge capacitor. Rails are connected by a rod. Charge capacitor. Okay. Rails connected by a rod. Mass m, length L, I guess R. Vertical magnitude is okay. Magnetic field is uniform. Vertical magnetic field is uniform. Okay. Rod is initially at rest. Magnetic field just move कर रहा है. What? How? अच्छा, current. Yeah. What should be the mass of the rod so that the kinetic energy in the steady state is maximum? Steady state? Kind of a weird thing. Under steady state, it's maximum. Okay, so as it moves, it induces the current. So like, interesting, very interesting. So initially क्या हो रहा है, current आगे जा रहा है, right? जब ये बढ़ेगा, then it's like north pole ऊपर, so just have to produce downward north pole or something, right? Yeah, so उसके लिए तुम्हारा current is actually going in this direction. So that's actually retarding the thing, right? Yeah, that will retard the thing, that will make it go in this direction. Okay, whatever. And what you are saying is कि, what do you mean by that? Steady state is maximum? Huh? Kinetic energy in steady state is maximum. Should be the mass of the rod so that this happens. What do you mean by that? Steady state कहाँ पे? इसका steady state कैसे हो सकता है आखिर? That doesn't actually make any sense. Long conducting rails, resistanceless. Okay, interesting. Think steady state कब होता है ये? I don't know. So that will happen whenever just like सिर्फ 4 0 हो जाए, which means कि इसके थ्रू करंट ही ना बहे, right? इसके थ्रू करंट ही ना रहे. Oh, okay. So till that point जब भी काम किया, right? So when current is equal to 0, तब इसका V क्या होगा? That's basically what we want, right? Okay, cool. देखो कुछ equations. It's got what? इसके अंदर like let's say voltage is like I guess Q is the best way to do. Okay, like Q upon C. So initially capital Q था जो भी है, right? So Q upon C, what should be the mass of the rod? हाँ ठीक है ना, for some certain capital Q. Q upon C is that voltage जो आगे जा रहा है. Okay, pushing current through it, and then right. Uh, you want to put the voltage is like okay, so यहाँ से तुम जा रहे हो. This got right. EMF produced in this thing, which is just yeah, ये चीज Q upon C. That is the thing. Oh, this was this potential drop, I guess. Yes. So minus IR. So that's the change in potential from here to here, right? That's basically EMF because like this is just integration of EDL, I believe, because yes, E is going from there to there, right? This is equal to what is equal to negative of the flux change. So plus and then तुम ऐसे जा रहे हो so your area vector is pointing up तो वो negative वो positive हो जाएगा, right? Okay, call it. So that's right. Just plus like BLV, magnetic field length velocity is like some flux change, of course. Flux change, yes, equal to 0. Also we know कि dV upon dt, or I should say negative because magnetic field is pointing in this direction and then current is going there. Like, wait, it's pointing outwards, huh? Okay, interesting. So dV upon dt is just equal to what? Is equal to magnetic field, current, and okay, क्या करा था इसमें? The length, of course, the length. Okay, good. इसको एक बार differentiate कर डालते हैं, and then that's good enough, right? Okay, so dq upon dt is just so as current proceeds, like okay, ये decrease होने वाला है, right? Just negative I upon C, that's dq upon dt. फिर negative R di upon dt. I don't think तुम्हें सब कुछ okay देख लेते ना di upon dt. Okay, weird. Negative I upon C. That okay, so dv upon dt is 0 when like I is 0, जो भी है. Negative R di upon dt and then plus b L dv upon dt, which happens to be just ये चीज. So just b square L squared I is equal to 0. Got it. तो ये क्या b square L squared plus 1 upon C times I is equal to R di upon dt, I believe. Right. मतलब ये क्या that इसमें नेगेटिव नेचुरल लॉग नहीं आएगा, right? Okay. So that is just how I wrote it. So, that's the thing, right? I guess it is. B square L squared plus 1 upon C upon R. Then like distance of T is equal to natural log of I going from something to something, right? Shit. Natural log of I. So initially कुछ भी था, finally कुछ भी रहेगा, right? Initially is just I naught or something. Wait, initially current था क्या इसमें? हाँ था ना. Initially था in fact. Initially, yeah, your current was given by this thing, right? Okay, that's wait. Velocity was 0 initially, right? ये तो मर गया. बहुत लंबा नहीं हो रहा है. हाँ हो तो रहा है बट और कोई तरीका नहीं है. ओके तो इनिशियली ये 0 था. योर करंट इनिशियली जस्ट आई नॉट बोल दो उसको. दैट वाज जस्ट q अपॉन cr, राइट? या सो फ्रॉम q अपॉन c I naught, ठीक है, till some I, which is like what natural log of I upon I naught. This should have been negative somewhere, but ये नेगेटिव तो नहीं है. Why did that happen? It's not negative anymore, right? But that's like saying the current increase हो रहा है, but it should decrease, right? Yeah, it should decrease. So probably यहाँ पे negative चाहिए अपने को. I guess that's the only way. It should be negative over there or something. Or maybe dv upon dt is negative. नहीं, we know that as long as current is in that direction, ये actually increase हो रहा है. So it is in fact positive. Just I cross E is actually in that direction. Yes, that's a thing. Okay. Area vector is in that. So मेरा flux change है. How is that? It's like it's positive and it's in upward direction, right? तो उसका negative is upward is like okay, it's causing right. इसमें ये ऐसा कर रहा है ना, it's causing this thing to be happening. मैं पागल हो रहा हूँ. The solution of EL is equal to जो भी है, I don't remember it. Anyway, this is the thing probably. सिर्फ ये नेगेटिव आना चाहिए, सॉरी यहाँ पे नेगेटिव आना चाहिए, मतलब कि ये it will just be negative over there, which means कि यहाँ पे negative आएगा, so then just have negative over there. So what I is equal to I naught and then e power ये सब. Got it. So what do you want? In steady state, of course, which is at t equal to infinity, I will just become 0, and at that point तुम्हारा v क्या हो जाएगा? Oh, you want to integrate this thing? Okay, so like v is integration of this thing to time, of course. इसको मैं k बोल रहा हूँ अभी के लिए, just pl squared plus 1 upon c upon r is equal to k for now, just e power negative kt, and you want to integrate this thing at v somehow. V is equal to integration of pl I naught, so, yeah, like I naught and then e power negative kt upon negative k. It goes from something like okay, t equal to 0 says let's just say like t equal to infinity, but something कुछ तो इसका v रहेगा, and also goes from 0 to infinity. Okay, equal to what? At infinity तो मर गया just 0 पे ये मर गया, just yeah, पे I naught है ना, exactly, just what pl I naught upon k, yep, which is pl I naught कितना है अपना, where is I naught? Q upon cr, okay, that's q upon cr upon k is what? K कहाँ पे रख दिया अपन ने? Yeah, this thing. So b square l square, I think, right? B square l square plus 1 upon c upon, yeah, that's really the thing, of course. Yeah, got it thing. Upon r. So ये just ऊपर जाएगा, ये cr मर गया basically. नीचे c भेज दो, whatever, just plq upon b square l square c plus 1. Finally done. So we will just be this thing. So अपने को क्या करना है? We want, what should the mass of the rod is that this is maximum. Shit, this is not negative d upon dt. It's actually just m. भूल गया मैं. Yeah. God. No. M dv upon dt. Oh no. Force. dv upon dt में इसमें upon m आएगा in that case. Nothing big. Only that ये थोड़ा सा चेंज हुआ, बस उतना ही है हर जगह पे, उतने बस चेंज हुआ है, नथिंग एल्स. सो जो k आएगा इसमें यहाँ पे अपॉन m आ जाएगा, दैट्स इट. और ऑफ कोर्स ये जो इंटीग्रेशन आएगा उसके सामने m आएगा. ओह नहीं, इसमें बड़ा अपॉन आएगा, m dv अपॉन dt दिया. सो अपॉन m k, इसमें जस्ट नीचे एक m भेज दो, दैट्स इट, दैट्स ऑल दैट मैटर्स, राइट. सो ये एक्चुअली क्या होगा? तो once again same stuff, it's just pl q upon c upon p square l square plus m upon c. तो नीचे c भेज दो, just get pl q upon p square l square c plus m. Yeah, so v is just this thing. So what should be the m such that what is kinetic energy to maximum? So just want half mv square, which is, ये क्यों मुझे से तड़पा रहे यार? डोंट गेट इट. पहले तो निकाल लो कितना होता है in terms of m, of course. So I'm gonna say m in milligrams. Okay, calm down, let's do it. So यार हाफ mv, इसका स्क्वायर करना पड़ेगा. ये तो कांस्टेंट है, फर्क नहीं पड़ता. m अपॉन ये चीज का स्क्वायर, b स्क्वायर l स्क्वायर c प्लस m, इसका स्क्वायर. यू वांट टू मैक्सिमाइज दिस समहाउ, राइट? ये जस्ट क्या हो जाएगा, 1 अपॉन bl, okay, upon square root of m thing plus square root of m का square. This should be what? This should be maximum. तो इसको अपने को मिनिमाइज करना है. इसकी मिनिमम कब आती है? when you have b square l square c is equal to m. Got it. क्या है? निकालो वो, just 4 times लेंथ कितनी है ऐसा है, just 1, then c capacitance of course 10 power negative 6. That's it, right? r तो ऐसे भी मर गया, फर्क नहीं पड़ रहा. It's just this thing, and this should be equal to m in kgs, that is, right? So in kgs it's just 4 times 10 power negative 6, which is, yeah, 4 milligrams. So 9th answer 4. ये इतना लंबा क्यों था? नेक्स्ट क्वेश्चन. It's got to 10 questions and then yeah. 10th is a uniform block of wood placed in water floats with exactly two-thirds of its volume submerged. Assume that the water has density something. The exact block of wood placed in oil floats with 5/6 of its volume submerged. Assuming using this information, what is the density of oil in kg per meter cube? Okay. Volume submerged कैसे निकालते? Like row um, of block upon row of, I mean, yeah, like row of block. That was the thing, right? Wait, okay, volume submerged times density of water or liquid or whatever. That's equal to total volume times density of block, right? 0.4 some stuff. Yes, like fraction of volume submerged. So F will there. That is what? That's density of block upon density of water. Yeah. So instead of water, that's equal to what? Uniform block of two-third hai initially, and then assuming that the water has density, like it is two-thirds of density of water, of course. And then, oh, that was very easy actually. अच्छा, density of oil अपने को निकालनी है. Right, got it. And density of the block upon density of oil, the exact same block of wood placed in oil floats with 5/6 of its. Right, okay, got it. So you want, what is density of oil? You can divide this, of course. So, again, density of oil upon density of water is equal to, just 1.2 आ जाएगा. Oh god, divide किया अपन ने, just take it 2, or you can just do this thing 6/3, just 2, 4 upon 5, got it. 4 upon 5 density of water, which is in what? Kg per meter cube. Times 10 एक बाहर निकल, just 2, 800 kg per meter cube. This is it. I guess we should stop for now. So let's see you guys next video. Bye.